Let's start. Oh, let's finish, I guess, the conference. So this is a final hot take of the conference, which is stated as drop your app services. Well, we'll see. This is a major hot talk of the talk. There are going to be some minor hot takes, probably out-of-band hot takes too. We'll see. And as you might guess, this is a talk about Rails and software architecture problems. But let's start with Rails and its architecture concepts. Straight from the guides, we learned that Rails follows MVC, Model View Controller, paradigm principles. Like models are to manage data, typically backed by database tables, views to render responses to user requests in different formats, and controllers to handle user interactions and map them to model updates, kind of. Well, actually this slide alone hides two minor hot takes. Can you guess them? Any suggestions? Any ideas? Yeah, feel free to, stand up and yell. That's a final talk. Everything is allowed. Anyway, so the first one is obvious. Rails MVC is not really an MVC as it was defined originally, right? We're not going to go into deep of that. Another one is very tricky. That's basically another talk suggestion for today. Well, I don't know if it goes better or not, but you don't need a server to run Rails at all. Because this is an example of in browser Rails tutorial that runs fully in your Chrome or Safari instance without any server or whatever. And that's a cool thing that you can do with Rails. And partially thanks to its architecture, actually, and its flexibility. But let's go back to the topic and talk about Rails MVC in its canonical form. So Rails gives you just three major categories, as folders, we know them, controllers, models, and views to put your logic into. And that should be enough. And we have some examples by 37 Signals, for example. They managed to feed the products into just a mere dozen of folders and just a handful of abstraction layers, and you should be able to do that too, right? But in reality, well, for a typical Rails developer, it's getting harder to feed all the business logic into just two categories as the application grows. So you end up with fat controllers, fat models, get objects, tons of concerns. It could be okay, but it requires a lot of discipline, a very high level of discipline to keep everything under control and not turn your code base into a mess. Well, that's one of the ways just to be disciplined. But we engineers prefer smart workarounds. So instead of that, what we do and what you can see in the real world Rails applications outside of Basecamp style applications. Well, a typical solution for answer the question, where should I put this, is just to drop more folders. Okay, we can add some mailer, like GraphQL, well, whatever, workers, services, and sometimes it's just one more additional folder, and it's the app services folder, but it covers everything that not fit the canonical setup of the Rails app. So the question is, why most applications that kind of a little bit deviate from the Rails way have this single folder present in their code bases? Why so? Well, I think the answer is that that's because the community cultivated this idea over the years that, you need to introduce service objects as kind of an architectural silver bullet to solve all your problems. We have tons of libraries, and the new ones appearing once in a while. We have a lot of talks about the subject, right? And we have blog posts as well, and so on. There are a lot of content, a lot of material about how your Rails apps would become better if you introduce service objects. And when I started working with Rails, like it was early 2010s, using service objects was just a must when you work with Rails. But every project had them, and every project had a different definition or a shape of a service object. And that's a biggest trick with service object. I would like to ask you, what is this service object in your code base? I bet you can't explain me that in just a single sentence. You probably need to write a book about it. No worries. I'm going to share some definitions that could probably help you to see if you're using service objects or something different, just called service objects. We can start with Godfathers. Oh, sorry. Yeah. So DDD. We already mentioned DDD a lot during this talk. So there is a very clear definition of a service object and the DDD concept. It's just an object that collects one or more services. Now let's define service. Well, it's a bit more tricky. But one important thing here is that it's about having some kind of a standalone operation. Martin Fowler gives a more detailed explanation of what a service layer is, with some requirements like encapsulation, business logic related, coordinating, and blah, blah, blah. What Rails developer use to define service objects usually? Well, technically, they just define service objects as anything between controllers and models, and that's it. That's a service object. Just put it there. Even more, a more simplified version of it, if it just doesn't fit anywhere, call it a service and put it in app services. That's what I see in the real life, and that's why I think that service objects as the category based on the folder is not a good idea, because we should not think in folders. We should think in abstractions. And abstractions are more than just being a pure Ruby object and having a call method. But who am I to say that, right? So, quick introduction here. My name is Vladimir of Vova, of Balkan, as we just learned from the raffle. And GitHub is the place where you probably see me from time to time, where I have some open source project like AnyCable, action policy, blah, blah, blah. Anyway, there's a lot of that stuff. Another important bit about myself is that I'm an Evil Martian. So Evil Martian is a consultancy focused on DevTools startups mostly these days. And I'm leading a backend team there. So I'm working with startups and our team and all research work and such. And fun fact that Martians tried to invade Bulgaria for a long time, and this is my second attempt, and I'm really happy to see many familiar faces as well as meet new Ruby friends here. So thanks to all the organizers and everyone shaping this event and the community behind it. So I'm very grateful to be here tonight. All right, one last bit. You already know about that. Thanks to Nick. But I have a book, even kind of two books, just two editions of the same book. And it's about building maintainable Rails applications and what does that mean according to my taste. And it's about the layered architecture principle and so on. And of course, in this book, I touched the topic of service objects just a little bit. It's not even a chapter. It's just maybe third of a chapter. And but there's one thing that I think is important for this talk, is the concept of a waiting room that I introduced along with the services. So what is a waiting room and why it's essential for today's talk? Let me briefly explain it. So it's basically a combination of two ideas. First, I believe that having service objects even without any clear shape or interface or whatever is beneficial for most Rails applications. You just can't put everything into controllers or models. You need some intermediate, place to store complex business logic operations or whatever. But the problem is that the services layer in its typical form can quickly turn into a mess, and you need to regularly visit what's going on there, identify patterns and use case, and extract specialized abstractions. So to keep the number of unspecialized or faceless abstractions low. The problem is that most Rails teams stop at the first step. They just, okay, we introduce services, let's start putting everything there, and let it kind of rot in vain. So in the rest of the talk, I'd like to demonstrate the concepts of the waiting room, or how could you apply the idea of, okay, let's take a look at our services and see what actually should be there, what should not be there, how we can improve the, the interface, the specialization of this object, based on some open source examples. So I took a few open source Rails apps and decided to look at how they implement their Rails they service objects. These are very different Rails applications built by different teams at different times, very different tooling and architectures, some old ones, some new ones, and so on. But they all have one thing in common. They all have the app services folder that's worth sorting out. So I'm going to use them to demonstrate the most common examples of misusing or overusing service objects in Rails. And I call such kind of categories of misusing as drop candidates. And we're going to start with a simple one. So it's just a random stuff that you put into app services just because where else? And the list of typical random stuff in app services is long. Basically, though, the objects that don't even pretend to be services from the context of the kind of layered architecture do not play a role in the business logic orchestration or whatever. They just live in the folder. They just introduce noise. They just make it more confusing working with the code base. Some examples from the applications I've mentioned. I'm not going to attribute them to a particular code base, but you can figure it out yourself. So this is an example of a very basic service, which is just basically a wrapper over a system command. It does almost nothing beyond that. You might think, oh, yeah, there's some result objects, there's some convention probably, maybe it's worth it. Not really. It's never used. We don't use this return value anywhere. It's just there just because we inherited from base service for no reason. This is not a service object. It's just a utility tool like infrastructure layer wrapper. And you should put it somewhere else, not in your app services folder. One quick note here is that there's actually one interesting part here. We see that it's located in the app services utils folder. And whenever you introduce a utils folder, you just creating a junk drawer within a junk drawer. So that's the first sign of misusing the concept, misusing the abstraction. And it actually applies not only to Rails, but to anything else. The utils is not a conception, it's just random stuff. All right, another interesting example here is like a server's kind of service that generates random phrases to greet people somewhere on some kind of chat or platform, I don't know. It just consists of dozens of methods that do sampling over hard-coded string contents, so it's like sentences. And it knows a bit about the user, so it's not like pure infra, right? But what is it? Actually, it's just a helper. It's just a good old Rails helper that should be a Rails helper and nothing else. But I would probably extract all the hard-coded strings into YAML files, even like internationalization API, and keep it slimmer. But it's not a service. Well, that's a final one example here. This is the service that an example of using an extraction pattern. You know, there are some developers that read books, good books actually, but they try to use the recommended refactoring patterns without thinking actually about what they're doing. And the most popular example could be probably extract method or extract class. Well, just because Ruby yielded to you, oh, your class has too many files, too many lines. Let's do something about it. Okay, we extract in this one line, a kind of a one method module, but it's used only once in a dedicated model. And by extracting it, we actually break the cohesion between the logic that is kind of present here. The solution is just to move it back to the model, move it where it belongs to, because you don't need it anywhere. It's not a service as well. It's just a regex checking. So there are many more examples of random stuff. I'm not going to go through all of them, but just quick examples of what I found there. Like, this is the most tricky one, generating SQL fragments as a service. I don't know. Anyway, so there are many stuff that you just put into app services because you are maybe afraid of creating new folders, or you just don't know what to do about it. But you should be more conscious when you think about locating code in your code base. If you don't know what to put, just create app random and put it there, just to make it clear to everyone that you don't know what is it, but you need it anyway. So one of the outcomes of introducing kind of a garbage into the app services, and especially enforcing some kind of a conventions like using base services, for example, for helpers, is that you can introduce the false consistency. But that's a separate topic. I'm going to explain it in a second. So what is a false consistency? It's not like a drop candidate. It's more like a symptom. And it looks like this. So if all of your objects in the app services follow kind of some contract. Here, for example, all service objects I mean, objects located in the app services, use the contract of having run as the entry point method, but they all do different stuff. And when different objects with different roles and purposes use the same interface, this interface means nothing because you don't actually know what's happening inside. It doesn't tell you anything. It's not descriptive. A more common use case, of course, is using call method. Everything is callable and nothing is actually telling you what it's doing. Having call interface for operations or maybe commands on workflows is probably fine, but for everything else, it's just an attempt to follow the convention that is not really working here. And it could lead to some interesting side effects, like here, for example. We have this service object, which inherits from base service and implement the call method, but it's nothing more than just a calculator. It's a pure domain concept. You don't need to use the whole service object machinery, and in this case, it's pretty heavy because it has middlewares, tracing, logging, and so on, just to do some pure mathematic calculations. It's just an overhead you can notice if it's in a hot path of your application. So the thing is that in this particular project, there are a lot of calculators. And some of them figured it out, and they, okay, we're going to deviate from this callable concept, and we just introduce a new interface method called apply, which just keeps all the middlewares and all the logic used in real services. But some calculators forgot to do that, and now we have the mixed interface and unneeded side effects. So that could happen when you just erase the intent of the object by enforcing a particular shape, which is not fitting the role of the object. And that could lead to unwanted behavior. There is another example of false consistency. It could be in different forms. That is an appearance of sinkhole services or sinkhole objects. So in general, sinkholes are objects that exist only to satisfy some layering rules while adding zero self-value. Let me show you some examples. So this is a service that just it triggers the background job and calls the very basic active record, like destroy method on the model. And it's used like that in the controller. So instead of, I don't understand why we can just move this code in line in the controller. What's the point of wrapping it into a service? That's because someone told, okay, every action must have a corresponding service. That's how we work. That's how we introduce sinkhole objects. That's how we introduce new layer of indirection and so on. And it's not only about controllers, of course. We can see the same pattern happening in workers or background jobs. And this way we introduce anemic classes, which are kind of also satellites of sinkhole objects in many scenarios. And that's a very simple examples, but I'm sure you can find such classes in your code bases. There are some sinkholes that I still consider sinkholes, but they might look like valid services because, oh, we do some side effects, some calculation here, and so on. It's not just pure wrapping active record methods. But when the same pattern is being repeated in dozens of services, when we copy paste in the same boilerplate, it's actually signaling us that, wait, we're probably missing some abstraction for side effects here. Instead of doing active record model like destroy or update and then triggering a notification delivery in a service object, we can just do that inline in the controller and add some controller level or whatever abstraction to trigger side effects. We can use conventions for that. We don't need to create dozens of services just for that. We can drop them all and replace with a single abstraction at the proper level. So that's an examples of sinkholes or examples of kind of overusing the abstraction. And yeah, okay, let's get a bit quicker and go to the most interesting part. So, in fact, we can drop random stuff, we can drop useless stuff, but there's still going to be a lot of stuff in the app services. And the thing is, most of it would actually be domain-level objects. And we can just move them back to the app models folder and organize properly. And that's exactly what 37 signals do. They heavily use models beyond active record, and they organize business logic using not only active record-backed models by other domain objects and domain services. It's like objects that coordinate only other models without touching any outer world or whatever. And whenever they need higher level orchestration, like involving side effects or whatever, they just use controllers, because that's what controllers are designed for. When we introduce service object, we tend to keep controllers like slim, almost anemic, just, oh, don't do anything in the controller, because maybe one day you're going to need to run the same logic from whatever else, so let's wrap into servers. But in most cases, it's not needed. That's a kind of signal of premature optimization. So I don't agree completely with the approach that you don't need services at all, that everything could be managed through like a combination of controllers, sprinkles, and models, domains, concerns, whatever. I think it makes sense to introduce specialized abstractions in between controllers and services. But I agree that many of the existing services in real-world Rails applications could easily be turned back to objects and domain-level services. Like, for example, the calculator thing we've seen in the previous section, right? So instead of keeping them as services, we can just introduce a calculator concept at the domain level, because it's actually a domain-level concept. It's not a service. It's not communicating with anything and not orchestrating anything. It's just producing numbers. And we could put them into the model. Well, it's just a kind of cosmetic change, but it gives us a bit more, because now when we operate within the same domain level, we can create a close integration with between calculators and the corresponding models. And we can go from this pattern using services from multiple, like Java-like code, like factories, class levels and stuff. We can just go the Rails way. We can associate calculators with the corresponding model, create so-called Collaborator objects. We can even introduce some gem to standardize that, unless you think that gems are overrated. But yeah, you can always copy-paste the contents. This is a very simple gem. But it gives you a convention of using Collaborator objects. That's important. It's not just random pour in your app models. It's a convention of keeping related, associated objects closer to their parent models. That's how you organize your business logic around the domain model, not about like operations, functions, or whatever. So another example is from a different app. It's a service. Those are service objects related to the award system. That's the one that assigns users, stupid badges no one interested in, but you have them like on GitHub or Reddit or whatever. They have systems like that in their code bases, and here they use services and verb-like names like award, thumbs up, for example, whatever. Let's take a look at the code of these services. Which responsibilities do we see here? Well, first we have the code responsible for scoping the users, like eligible users, for awarding a badge. Then there is a badge achievement record creation. Then we have this cache busting line, which is useless because we already have this in the model, but it seems that no one knows, the person who wrote this service didn't know about it. If we take a look at some other examples, we see that, sometimes it's missing. There is no consistency because there is no convention, there is no abstraction, there is no clear interface for this cluster of services, yet still services. There is also another version of the same service, but now for some reason we decided to split the logic between three files, probably in an attempt to introduce a generic interface for awarding services. But anyway, this is an example of a lot of like a boilerplate which is diverging at every copy-pasting operation and is likely to at some point to introduce just bugs or some regressions in the code base in the application. But why not consider badges or award rules or criteria as domain objects as well, because that's what they are actually. Because all we need is to know about who are the qualifying users, and basically that's it. And we can refactor this piece of logic like that. So just keep a single service object to grant achievements, and every badge will just have its object-like representation with some API, similar for every object, and easy to understand. You look at it and say, okay, who are qualifying users? Zoda, qualifying users, that's fine. This is the name of this badge, and so on. And we can move, kind of demold these services back to models, because those are just domain concepts. So, no, it's a ring. Okay, sorry. To sum up here, so take a look at the service and see if they're really actions or activities, or they're just objects that are disguised as operations. Do they describe your domain model, or do they describe communication between your domain objects? Think in objects first. Yeah, this is kind of not functions of operations when you design your business logic of your application. But even after we remove the junk and image objects and identified domain objects in your services, that's after that, and we need to figure out what to do with what's left. And at this point, we're looking for emergent abstractions that would be new abstractions, probably within the service layer, or maybe in between services and like controllers or services and models. We can create more layers if we need, but we can try to find them. Because what if it's really a service? It's not a model, it's not a random stuff, it's not a sinkhole object. It should live somewhere. But even for such objects, we need to try to find the common patterns used in your service object to identify clusters of specialization clusters and promote them to proper abstractions. So we can reduce boilerplate, we can enforce boundaries to make them clearer and easy to understand and use. So let's take a look again at the example of emergent layers in the projects under question. Here, in one of the projects, we have this emerging notifications layer. So this is this combination of workers and service objects and even model extensions that are responsible for delivering notifications to users through various delivery channels, like in-app notifications, push notifications, whatever else you want to add next. But right now, it's still kind of emerging abstraction layer because it has no clear convention, has no clear shape. We can see that, yeah, we can probably spot events here and delivery channels. We can see there are corresponding workers, but they all anemic, and I don't think we need a worker per notification type, right? That's kind of architecture smell. We can see that the model is also looking suspicious. We add a method or two for every notification type, just for no reason. I don't know why. And I don't know why some of them have delay and without delay versions. There is no consistency here. And there is no clear vision of how to approach maintaining this layer, how to add new notifications, how to refactor old one. It just increased the cost of maintenance. We also have some payload generations, which is, again, for some reason we just have some helper-like module and some separate objects for generating hashes, like payload hashes. It's very inconsistent. It's very hard to understand what's going on here. Instead, what we can do instead, so for notifications is one of the typical examples of the abstraction layer that many Rails applications would benefit from. We can introduce the concept of a notifier, for example. A notifier object that would encapsulate everything related to a particular notification type, like how to generate payloads, how to select recipients who must be ignored or not. We can have a base class with all the logic regarding background or synchronous delivery. And we can have a very clear and well-defined interface for that. And that's just a random example. It's kind of pseudocode. It's not a real thing. But it might remind you, again, existing patterns from some gems, for example, that already exist. And they exist for a reason, because many applications suffer from this problem. And in some cases, it's a good idea to look at existing tools, especially popular ones, and see why they've been implemented, are usually extracted, and introduce them. And, well, I guess, unless you think they're overrated again. So there are a bunch of common service specialization in Rails apps that you usually see and tend to extract if I see them. It could be form and query objects, notifications already mentioned, authorization, AI agents, and so on. It's easier to spot them in your code base and promote to proper abstractions. Because why do we need that? Why do we need a proper abstraction? Because you can do better if you pick the right abstraction for your code, right? And if you pick a right tool for your code, you can do better, even more better. All right, no one talks like that. So the emergent abstraction part is the most important, I think, here, because it's about kind of a self-reflection and reflecting against your code base, trying to understand what it really needs. Because when you want to introduce an abstraction, you just don't do that because, oh, it's a cool new thing, let's use it in my app. I used to be like that, like 10 years ago, because, oh, I saw a talk about like some service object, maybe form objects, let's go to add to the app. But if it's not needed, you're going to make things worse. So extraction is the core requirement for introducing new abstractions. Like not being dogmatic with using services, you should not be dogmatic about using abstractions if you like them. And yeah, so that's also something we just learned about it, because the abstract itself means that it's extracted from a larger work. And in the case of your code base, your code base is already a larger work, so extract from it, not from the blog post or conference talk, even my talk. So that's about emergent abstractions. But we continue our refactoring of dropping our services. But in this case, we're not dropping them, by the way. We just reorganizing them. But anyway, the last bit of this operation is actually to keep what should be there. Because, again, there are real service objects that reflect business operations, that reflect workflows, that belong to this layer of the application, that do not belong to models or controllers or wherever, or do not have a very specific role like authorization or notifications. There are good, what you need to do with them is to bring them to a better shape, to turn them into a proper abstraction as well, because there could be a service object abstraction after you get rid of all the secondary stuff. You might be asking why I put this picture on the slide with a drunken Tom and a barrel. But that's actually the secret ingredient behind this idea of right shape of an abstraction. And it's not about drinking as much raki as possible so you don't care about the high matter, right? It's about different thing. And it actually comes, it's a new stuff. It comes from the tale I read very recently. We were preparing for the trip with my son. So I read this tale about the barrow. And it's about an old man teaching his sons about the importance of agreement and the family is a barrow, and so on. And I decided, oh, well, we could apply this concept actually to code, right? And how I tried to apply it to code. So let's see. So we can see our code base is as a barrow. Then every stave or wooden plank, right, that makes the barrow is an abstraction layer. Then we have hoops that are conventions that keep them together. And the question is, if everything fits each other well, everything is polished, has no cracks, and is tight enough and strong enough, conventions, to keep the barrel keeping what's inside. What's going to be inside? Inside we're going to put the wine. And the wine is the developer happiness of working with maintainable code. So if your planks are rough, not polished, have cracks, or your hoops are not strong enough, the wine is just leaking. You lose the happiness of working with your code base. And that's basic principles, having polished interface, clear API, and strong conventions. That's how you introduce proper abstractions that make working with code a pleasant thing, not a pain. I tried to look at the code bases I mentioned before, like at the projects, and try to find, oh, do they have anything like that, really? Do they have kind of good-looking abstractions? And I found a couple of examples. One is an example of the kind of outgoing webhooks layer in one of the projects. And it has some traits of the good abstraction. It has a base class with shared machinery and a clear interface, clear naming convention, test utilities to make working with these objects and tests easier and standardized, because that's also one of the criteria of a maintainable code, because maintainable code must be testable. And it's not a perfect example because it still lacks a speciality in its naming conventions, like it's still service suffix and call interface, but it's better than most of the stuff I've seen in the code bases mentioned before. And another example, it's probably more interesting because it's a full-featured service object layer with a DSL to define inputs, steps, guards, and populate the result object. They have a clear convention on how to use it. And also, you can see that actually it has some boundaries because it also encapsulates authorization within service objects. So you have a dedicated place to where to put your access control checks. Personally, I'm not a big fan of mixing everything into service objects. I prefer to have authorization as a separate layer. But if you discipline enough to keep your authorization in one place, that's better than not having it everywhere. And it's really cool interface, right? I mean, it kind of reminds me some stuff. Maybe someone else also found something familiar here. But it's very similar to the ideas behind like Trailblazer operation and other parts of this framework. I don't know why. This is an old project. They probably started way before they learned about Trailblazer. But I found it's very similar, and we have good examples of maybe not, you don't need to use a library. So speaking of Trailblazer, I never used it in my life, but I inspired a lot by the ideas behind it. I just re-implemented them myself, but yeah. And the only reason I didn't mention them in the first book because I was in a rush writing it. And yeah, I fixed it in the second edition, so properly. Anyway, so you can make service objects the right way. You can build proper abstractions out of them and benefit from them. So you don't need to drop them in that case. One thing I want to add about this particular abstraction from this object is that it comes with something that's very specific to year 2026. Because in addition to DSL, test helpers, interfaces, and whatnot, it also comes with a skill for AI agents to follow the rules, to follow the ideas behind it. Actually, the skill is very long, but it describes all the possible rough edges when picking what to put into service objects and what not, when to use them and when not, and so on. And that's a new realm. That's what's actually the new ingredient of a good abstraction in 2026 and going forward, is the conventions for robots. Conventions now go beyond humans. And I want to talk a very little bit about this aspect. Yeah, about services in the AI era. So, so far we've talked only about how humans can spoil the app services folder, right? But what about AI? Maybe it has a better sense of software design. Like maybe it knows when to use and when not to use services. I don't know if you tried that or not, just to create something from scratch. But the problem is that, as we know, AI is an amplifier, right? Whenever you put in, like in terms of quality, you get out. And LLMs were trained over code bases with slim controllers, slim models, and fat services. And by default, they tend to introduce the same pattern into your code base. If you just start from scratch, you're going to end up with the app services folder full of random stuff you eventually would like to drop. So to avoid that, we need to introduce some harness, they call it. So something that would guide AI in any form, whatever form you prefer. But we need to guide AI to properly use not only services, but other abstractions as well in your code base. Currently, the most popular way to do that is to use skills, Like, okay, markdown files, they call it skills. But anyway, and I have an example of such skill set, or skill pack, which is based on the book. It's just kind of the book distilled into skills for agents. And in the very recent version, just came out today for this talk, I added this new workflow or command called analyze services, and it basically does what I did during this talk, explaining what's wrong with your services layer. You can run it, you can see some kind of a top 3 actions, what to do first, what to consider with regards to your code base, what's in the wrong place, what's in the right place as well. One of the interesting part of it, and I'm sure if you see it, I like it the most because it tries to infer the definition of the service object based on your real code. And for most applications, this could be like, the answer could be, oh, it's just anything that responds to call. Or it's something that, you know, orchestrates whatever. Here we see some pretty long definition. It's probably not right, but, you know, who cares? So that's something you can use and try to apply ideas from it, and probably add additional hardness on top of your existing one if you have, to avoid your app services folder to become a droppable thing. So back to the hot take, enough AI, right? So drop your app services, my initial take, was just the first part of it actually, because as I already said, services could be designed well, and I don't see that very often in the wild, but that's possible. But the chances are that your waiting room is full of tech debt, so please keep an eye on it. Try to take care of it and see if maybe it's telling you something. Maybe it's telling you, oh, you need to move code around, extract abstractions, simplify it, whatever, introduce convention, and so on. And for that, maybe the only option is to drop it and repopulate again from scratch, but this time paying attention to object roles and meanings beyond just the callable interface. Oh, okay, just 2 more slides and we're done. And actually, they're a random one. All right, this is the credit slides. First of all, I would like to thank William Hanna and Joseph Barbera for the amazing characters I used throughout the talk, and my son Misha for inspiring me for using them. So, and thank you everyone for the great conference and for the great days in Bulgaria. That's it.